The first law of thermodynamics is commonly called the law of conservation of energy. It means that we can't create or destroy energy. However, it's easier for me to remember if we refer back to the title slide of the notes handout, where it uses Ginsburg's theorem. And Ginsburg's restatement of these says for the first law of thermodynamics, you can't win. You can't get back extra energy because that would violate this first law of thermodynamics. You'd be creating new energy, and it can't be created or destroyed. Now, since it can't be created or destroyed, the total energy of the universe is going to be constant. And also, we'll set this up so that we can refer to it with the signs that we have down here at the bottom. Change in energy will equal the heat energy and work done in the system or done by the system. So, let's actually take a look at what we're talking about for the universe, surrounding, and the systems. Total energy of the universe, well, the total change in energy of the universe will equal the change in energy of the system and the change in energy of the surroundings. But we can't create or destroy any energy, which means the total still has to be 0. Delta E for the universe will equal 0. And since these two have to add up to be 0, that means that the change in energy of our system is going to be the same magnitude, but opposite in sign from the change in energy of our surroundings. So when I've got my refrigerator, the amount of heat energy that I reduce inside the refrigerator has to increase on the outside. Now notice that means that in this case, for Q, the system is losing heat. Inside of here, Q is going to equal some value, and it's going to be negative. On the outside of our refrigerator, Q is going to be positive. It's going to be positive, and it's going to be the same size positive sign as this negative sign. Now, here we've got a mini problem set up for you. Go ahead and pause the video and try this out. A brand new refrigerator is plugged in. What is your system? Fill in your blanks with a positive, minus, or 0. Describe what the change in energy for the universe, their system, and your surroundings is after you plug in that refrigerator. Go ahead and pause and give it a try. Okay, well, the total change for the universe has to be 0. And I'm going to declare that my system is going to be the inside of the refrigerator. So if the inside of the refrigerator is my system, I'm seeing that the heat energy inside of my system is going to go down. I'm also not doing any work at that time. I'm just pumping it out. Well, there's work being done, but not inside of the refrigerator. It's in the machinery of the back of the refrigerator. So be aware of that. We're frequently going to have work being done somewhere in between, but we don't focus on that a lot of time. Okay, so change in energy of our system, we said that it's going to decrease by some amount. The change of energy of the surroundings, it's gained heat blowing out of the back of the refrigerator to the surroundings. So that one's going to be an increase. And these two numbers will be the same in magnitude. That's our quick reminder of how we handle the sign conventions for changes when it comes to thermodynamics.